All right, in today's briefing, we are diving deep into two of the most talked about compounds in metabolic research right now, retatrutide and cagrilintide. We're going to break down exactly how they work, what their research applications are, and what makes them so different from each other.
Now, this entire explainer is based on information put together by Buyreta. They're a provider that's really committed to a science-first approach, making sure that researchers have access to high-purity compounds with total transparency. And let's get this out of the way right up front because it is absolutely critical. This is the legal notice that frames our entire conversation. Everything we're about to discuss is strictly within the context of lab work and in vitro research. For years, the research community has been laser-focused on GLP-1 agonists, but the field is moving so fast. So the big question is, what's next? Well, the two compounds we're about to explore might just be the answer to that. First up, we've got retatrutide. The thing that makes this compound so fascinating for researchers, it's its unique identity as a triple agonist. So what is it? Developed by Eli Lilly, retatrutide is this incredible peptide that's been engineered to activate 3 different metabolic receptors all at the same time. This multi-target strategy is a pretty huge leap beyond the single or even dual agonist compounds we've seen before. Okay, let's really get into this, because this is the core of what makes retatrutide so special. First, you have the GLP-1 agonism we're all familiar with. It acts on that key gut hormone for appetite signaling. Then you add GIP agonism, which targets another hormone to potentially enhance things like lipid metabolism. And then here's the really interesting part, glucagon agonism. This is being studied for its potential to crank up energy expenditure. It's this 3-pronged attack that gives researchers such a massive canvas to work on. Now, for any researchers out there designing experiments, these are your key specs. Check out that half-life of about 6 days. That's what makes weekly protocols in clinical trials possible. And, of course, it comes lyophilized, or freeze-dried, for stable storage. And to really underline how significant this is, retatrutide isn't just some concept molecule. No way. It is deep into phase 3 clinical trials right now, part of Eli Lilly's TRIUMPH program. That makes it one of the most advanced peptides of its kind in the entire research pipeline. All right, now let's switch gears and talk about our second compound, cagrilintide. This is a whole different ballgame. It works through a completely different pathway, and it's all about a peptide called amylin. Cagrilintide, which comes from Novo Nordisk, is what you call a long-acting analog of amylin. Amylin is a natural peptide your body releases along with insulin. This version has been engineered to stick around longer and be more selective, which makes it a really powerful tool for studying how appetite is regulated. What's so cool about this mechanism is that it's centered on the brain, the central nervous system. Cagrilintide's main job is to hit amylin receptors in the brain to signal that you're full. Yeah, it also affects things like gastric emptying, but its core function for researchers is studying these neuroendocrine appetite pathways. It's just a totally different approach from retatrutide. Looking at the technical details, you can see it's a little bit smaller than retatrutide, with a slightly longer half-life of around 7 days. And just like retatrutide, it's supplied in that stable, lyophilized form, ready for the lab. Now, this is a super important point about cagrilintide. It's often studied as a team player. It's actually the key component of something called cagrisema, where it's paired up with semaglutide. This combination is being studied in a massive phase 3 program called REDEFINE, which just shows how much interest there is in these multi-compound research strategies. So what we have here are 2 really advanced compounds, both in late-stage trials, but they have fundamentally different ways of working. So how do you even begin to compare them for research? Let's do just that. We'll put them head-to-head to really clarify their distinct profiles and see where they each shine in a research setting. And this table really tells the whole story, doesn't it? You've got Eli Lilly's retatrutide with its broad, triple receptor attack, focusing on overall metabolic health. Then you contrast that with Novo Nordisk's cagrilintide with its laser-focused amylin pathway, aimed squarely at appetite regulation. It's like 2 different philosophies from 2 industry giants, both at the absolute cutting edge of research. But here's the thing. None of this research matters if the compounds themselves aren't up to snuff. The quality is absolutely non-negotiable, and that brings us right back to the source and the importance of quality control. When these compounds are sourced from Buyreta, both retatrutide and cagrilintide are supplied at a minimum purity of over 98%. That's the standard you have to have if you want reliable, repeatable experimental results.
And this isn't just a claim they're making. To really drive home that commitment to transparency, the purity for every single batch is confirmed by an independent certificate of analysis. And researchers can see it for themselves. That kind of verification is just essential for any kind of serious scientific work.
And so, we're going to end right where we began, with what is hands down the most important message of this entire briefing. I'm going to read the full notice. All compounds supplied by Buyreta are intended strictly for in vitro and laboratory research purposes only. They must not be used for self-administration, clinical application, or any purpose other than scientific research. For the entire research community, understanding these incredibly powerful tools is every bit as important as using them responsibly.